Thank you so much, Laura, and thank you everybody for being here. Actually, I would like to be there with you. I'm sorry that I couldn't be in presence for reasons that I will explain in a second. I see already my slides on the screen, so probably I will ask you to control them somehow. So let me first say just a few words on the title I chose. I'll try to build upon the title of the session, Equitable Sustainable Solutions, Multi-Agent Models and Instrument Analysis, focusing on a specific instrument, carbon markets, that are gaining increasing attention nowadays, and asking whether these are an effective and, as the title says, equitable and sustainable solution. So next slide, please. Just to make sure we are all on the same page, some background information on the instrument. Well, as most of you probably already know, carbon markets are also known as cap and trade instrument, because the regulatory authority sets a cap, a maximum amount of pollution allowances, and then allocates them among the polluting companies. And polluting companies then trade allowances among themselves, and this leads to a market price for the polluting emissions. So in this way, applying the so-called polluters pays principle. The first and most prominent example of carbon markets is the European one, also known as EU ETS, which stands for European Emission Trading System. It covers 40% of European emissions, more than 10,000 installations across 30 countries. It started in 2005 and was divided into 4 phases of increasing length, and we are now in the 4th phase, which covers the whole decade from 2021 to 2030. And as time goes by, the policy has become increasingly stringent. Namely, the cap has decreased, thus reducing the number of allowances at disposal, and it has decreased faster and faster. At the beginning, it decreased by 1.74% per year, and now we are at, it decreases at 4.2% per year, and it's bound to increase even the speed even further. As a result, the European emissions from the regulated companies in the regulated sector, so mainly European power and industry plants, experience a fall in emissions by around 47% by 2023 compared to the beginning of the program in 2005. And indeed, if we move to the next slide, please, you can see that the sectors that were regulated, so the energy supply in blue on the top and the industry sector in light blue, have decreased much faster than the other sectors at the European level in terms of emissions. The other sectors actually did not decrease their emissions, or in some cases, actually they increased them, as in the case of the domestic transportation, the line in red. Next slide. Over time, I would say that carbon markets have become a sort of companion of life for me in both personal and professional terms. I have directed, as director here at the Florence School of Regulation of the European University Institute, 3 live projects on carbon markets: LifeSite 2016-18, DCET 19-22, and now I'm directing the Life Cause program. And the project Life Cause, the title code stands for Collaborative Observatory for the Assessment of the EU ETS. It wants to create an observatory across the carbon markets. And the acronym CAUSE is a tribute to the Nobel laureate Ronald Coase in the picture. The project is running now, and it will run until the end of next year. And it actively involves the regulators of the main carbon markets worldwide. So the European Commission for Europe, and then regulators of China, New Zealand, California, Quebec, and Switzerland, plus some other governments who are participating as observer in the discussions, like Brazil, Canada, or UK. And in the picture on the right, you see a moment of what the Commission call on the webpage the Florence process, because it is taking place in Florence, here at UI. And it's a sort of, I call it a lab experiment of collaboration on this specific topic across the governments of different countries. Next slide. So the number of regulators participating is increasing around our table, but also the number of carbon markets is increasing. And this can be seen by this diagram that compares the extension of carbon markets, the spreading of markets from 23 to 24. As you can see at first sight, the number of jurisdictions that are covered by carbon markets is increasing on a yearly basis, I would say. And we now have 36 jurisdictions that adopt a carbon market, those in blue in the diagram, and then 12 where these are under development in green, and 8 where they are under consideration. So as of today, 55% of global GDP is covered by carbon markets, and 1/3 of the global population and 17% of greenhouse gas emissions are covered by the markets. Next, please. Not only carbon markets are spreading, so increasing in size, but also the prices are increasing. And this diagram taken from ICAP shows the price trend in the main carbon markets, or ETS, whatever you want to call them, from their beginning up to now. So look at the blue thick line. This is the European carbon price. As you can see, the price was very low at the beginning for many years, I would say, until the end of 2017, when the announcement of a new instrument, the so-called Market Stability Reserve, which automatically adjusts supply to demand, increased the credibility of the system. And as a consequence, it increased prices as well. So the price went up. They reached also 100 euros per ton of CO2 at some point. And that decreased due to the energy crisis, I would say mainly to the energy crisis, but still it navigates around 70 euros per ton of CO2, which is much higher than the 5 euros we experienced for many years. And also the other jurisdictions experience an increase in carbon prices. Here you see in green, California and Quebec that join their systems, so to create a unique carbon market. In blue, you see the New Zealand carbon price. In green, dark green, the Swiss carbon price. Switzerland joined the European system, so the price went up and now moves hand in hand with the European one. And finally, in what is purple also, you see the UK. UK, contrary to Switzerland, delinked from the European ETS after Brexit, and it experienced a fall in price. But the price of the UK ETS, as you can see, is moving in parallel, basically, to the European one, although at a lower level. And there are rumors that the two systems might be linked together in the future. Next. So far, I look at the historical trends. What about the future? Under the Life Coast project, we are looking at the expected evolution of prices in different jurisdictions. So here you see on the left the map of the jurisdictions at stake that are studied with different models. And on the right, the price trend in China and New Zealand, US, Canada at the global level, and in the European and UK case. I won't go into the details, but as you can see at first sight, most scenarios predict a rapid increase in carbon prices, up to 150 to 100 euros per ton for China, 250 or more US, and around 400 or even more for Europe. The other thing that we see is that uncertainty increases as we go farther into the future. So the price trends that are predicted tends to diverge in the future. So telling us that there is still a lot to understand about the future evolution of these prices. But the overall consensus seems to be that as policies get more and more stringent, prices will inevitably increase. Next, please. So this leads to what I think are the next challenges for the European carbon market, but also for the other carbon markets in a way. First of all, we will need to address the distributional concerns that come along with increasing prices. Secondly, the competitiveness concerns, because the European carbon price is much higher than the others, and many jurisdictions have no carbon price. So there is a concern that this might lead the domestic companies to delocalize their production where there are laxer or no environmental regulations. But there are also other challenges. The extension to new gases, like the methane emissions that are particularly severe problem, or new sectors. Europe is already working on what is called ETS2, so on maritime, buildings and transports. But there are rumors that the ETS system could be extended to the agricultural creating sector, thus creating an ETS3 in the future. Another problem is the needed reform of the market stability reserve. The instrument, as I said, worked very well to increase the credibility of the whole system, but we are navigating difficult times, and so there are new challenges which might require some reform in the MSR in the future. And finally, what I define as the new frontier of emission trading system, negative emissions and voluntary carbon markets. Now, given the time constraint, I will focus only on two things, the first and the last, and I will start with the distributional concerns. Next, please. As I said, carbon prices have been increasing, and this is likely to have regressive effects because poor households spend larger income share on carbon-intensive goods, face higher financial constraints to adopt low-carbon technologies, and are more likely to suffer job losses in carbon-intensive sectors. So this raises the question that we should look at, namely about the social acceptability of higher prices. The question is basically, how can we increase this acceptability? And the literature provides some answers. For instance, in the works by Caratini and others, we see that the acceptability depends on how carbon pricing revenues are used. And so this leads to new questions. Are they used properly? Are the carbon pricing revenues enough? And how do these revenues change with carbon pricing? To answer this question, let me move to the next slide and show you some trends. This diagram shows the EU ETS auction revenues from 2010 to 2023 on a yearly basis. And as you can see, these revenues have been increasing almost steadily and could be fitted by an exponential curve. So they're growing very fast. And actually, as we see in the next slide, they have become the main source of revenues. According to this World Bank study, you can see that the ETS revenues at the global level, those in blue, have become much larger than the carbon tax revenues at the global level in red. So ETS revenues have reached basically in 2018-19 and then overtaken carbon tax revenues. And nowadays, they are around 70% of these global revenues. Moreover, as we will see in the next slide, they are expected to increase even further. In an interesting study by Clemens Fuest and Jean Pisani-Ferry, it was estimated that the ETS revenues in Europe might range between 800 and 1,500 billion euros by 2050. Just to give you an idea of the order of magnitude, this might double basically the coronavirus aid package that Europe implemented, although on a much larger time scale, but it's a huge amount of money. On top of that, the Social Climate Fund is expected to rise 86 billion euros, 65 from auctions and 25% from member states, over the period 26-32. And this additional fund is planned to start to compensate vulnerable sectors of the population for the increases in prices in buildings and transport with the ETS2 system. And finally, auction revenues are likely to increase with higher prices. So more stringent policies will lead to higher prices, and thus revenues will increase. But how will they increase? Probably not hand in hand with the price. In this diagram that is taken from a recent study with a young colleague, Matteo Mazzarano, we are analyzing the trend in price in green and in revenues in brown. And as you can see, at some point there seems to be a decoupling between the two trends, with prices that keep increasing but revenues that start falling. Why is that the case? Well, one possible explanation is that as price goes up, the demand of allowances will decrease. Hopefully more firms, more companies will move to clean technologies, and this will reduce the quantity of allowances. Thus, at the end of the day, this may more than counterbalance the increase in price so that the revenues at some point might decrease. And to check whether this is the case, we perform some econometric analysis. And in the next slide, you can see in a very synthetic way the relationship that we find between prices on the horizontal axis and revenues on the vertical axis. And as you can see, revenues first increase and then decrease as prices go on, depicting what we can describe as a sort of carbon Laffer curve, with the vertex of the curve around, with a price that is around in the range at least between 85 and 125. This is what we find in our estimations. And this is interesting because it is not far from the prices that we experience in the EU right now. So we might be close to the vertex of this curve, and then revenues might start decreasing in the future if the prices will overcome that level. So far, I discussed the distributional part and looked into the future, but how long in the future should we look? In the next slide, I will discuss what has been defined as the end of the game by Michael Pale and other colleagues. They wrote this interesting article in which they estimated when the allowances will get to zero if the cap keeps decreasing at the present speed. So in their estimation, Pale and others find that the cap will go to zero by 2040. So even before the target of 2050. As you know, we want to achieve net zero emissions by 2050. And by net zero, we mean that by 2050, we will need to compensate all residual emissions in the so-called hard-to-abate sectors, so cement, steel, and chemical, for instance. But for this to happen, we will need to have sectors that can absorb CO2. So we need negative emissions technologies, whether they are nature-based, like afforestation and reforestation, or technology-based, like direct air capture and carbon capture and storage. And this opens up the door to a new kind of carbon markets, the so-called voluntary carbon markets. So far, I described the regulatory or regulated carbon markets, compliance carbon market, but there are also a new kind of markets that are emerging on a voluntary basis, in which companies that are able to avoid, reduce, or absorb greenhouse gases can sell their carbon credits to companies that need to compensate their emissions, companies that belong to the hard-to-abate sectors. This leads to a set of new challenges. And in the next slide, I listed a few. So, first of all, there is a problem of scientific integrity and transparency because there is strong uncertainty on the credit's value. Secondly, we need to assess the co-benefits of the absorption, reduction, removal actions in terms of social biodiversity and ecosystem restoration co-benefits. Then we need to ensure that the removals are permanent, and this will require a close monitoring over time, but over a very long time period. We are talking about a century or so. Not only monitor over time, but also monitoring across countries, so over space is needed, because there is a geographical separation between those who sell the carbon credits, often located in developing countries, and the companies that need to buy them, often located in developed countries. And this leads to the point 5, what in a recent paper with some colleagues we define as carbon grabbing risk. So the risk that some companies might get carbon credits with no adequate remuneration to the local community. This leads to the need to set a minimum price if we are to ensure equity and the credibility of the voluntary carbon markets. And also leads to the need to have interdisciplinary studies that involve many disciplines to get the right value of these carbon credits and all the stakeholders that are involved. And actually, this interdisciplinary approach, which I know is in the spirit of the project that we are launching now, it's also somehow in the spirit of a project that I'm leading at the University of Siena on this topic. The next slide will describe very briefly this project that is called Agritech, and which tries to assess the offset potential of the Italian agri-food sector. It's again what I like to define a lab experiment with local firms, trying to build up a data set and a platform for possible exchanges, trying to explain to the agents involved the potential gains but also problems of voluntary carbon markets, and promoting new sustainable business models. And this is a really interdisciplinary project that sees the participation with my group of scientists from many disciplines, because really we need information from all disciplines to get this price right. I think my time is almost up, so I will now come to the conclusion. In the next slide, I'll come back to the question I was asking at the beginning and the title of my presentation. We wanted to see whether this carbon markets, this specific instrument that is becoming more and more popular, can be effective, equitable, and sustainable. Well, I think that the carbon markets so far have proved to be effective in reducing emissions almost by design, because as the cap decreases, the allowances and thus also emissions will decrease accordingly. But the real challenge is what happens when carbon prices increase at a faster rate. So, in my opinion, despite this increase and despite the regressive effect they might have, they are still a potentially equitable solution if carbon revenues are properly used for redistribution purposes, because the amount of revenues that they raise is large, very large, and can be used for redistribution purposes. And they are also potentially sustainable as a solution if their functioning and effects are properly communicated. And in this regard, I think the carbon markets must be perceived as effective and equitable. And this is key if we want to have their acceptability and thus also their sustainability, so their capacity to continue over time. In any case, I also believe that there are one important key tool, but one tool among the others. So it's not a silver bullet. We should not rely on carbon markets only, but we should also consider the role of accompanying instruments to achieve net zero emissions by 2050. But this is the object somehow of future studies, and in this sense I can say that life goes on, and that's something food for thought, but for the future. And on this note I will conclude my presentation. Thank you all for your attention.